we're on lesson 9-8, guys, which is on modeling for adding and subtracting fractions. And what's going to be different about this is we're going to focus wholly on mixed numbers. So, looking at question number 1, it says, when adding mixed numbers. So remember, a mixed number is whenever we have a whole number and we have a fraction. And we call it mixed because we're mixing a whole number with a fraction. We're putting them together. So when adding mixed numbers, is it always necessary to rename the fractional sum? Explain. Well, it's asking, when we add mixed numbers, we'll just take this part and we'll add another mixed number and we'll just add the exact same one. They're saying, do we always need to rename the fractional part? Do we always have to rename these fractions? Well, the answer is no. What do you think would happen if I had this for my fraction? 1 1/4 plus 1 2/4. Do we have to rename it? Do we have to regroup this 3/4? No, because there's not a whole hidden in there. So how can we put that in a sentence? Well, we're going to say no if the numerator is less than the denominator. It does not need to be regrouped. And you could put regrouped, renamed, made into a whole, whatever you would like for it. Number 235, it says use fraction strips or number lines to find each sum or difference. Now we're going to use fraction strips just because that is a little bit easier. So we have 1 whole plus 1 2/5 plus 2 4/5. So what do we have here? Well, we have 3 wholes, and then we add our fractions, and we get 6/5. Now, looking at that, that means we have what? It means we have a whole hidden inside here. So we're going to take that whole out. It's going to be 5/5, and we add it to this part. So we have what? We have 4 wholes, and then we'd have what? Well, we'd have 1/5 left over because we took 5/5 out. So now let's head to our next one. We add our fractions together first. So we add 1/4 and 3/4, which gives us 4/4. And then we add the wholes together and we have 3 wholes. Now what do we notice here? Well, 4/4 is what? It's 1, 2, 3. That's equal to 1 whole. So we need to trade this 4/4 for 1 whole. We need to rename it. So we have 3 plus this 1 whole is what? Is 4. So our answer is 4. All right, over here, what do we have? Well, we start with our fractions. So we have 2/3 minus 1/3 is 1/3. And then we have our wholes. 4 minus 2 is 2. Look, this one we didn't need any renaming for. Now on for number 5. We start with our fractions. 1 minus 3 we can't do, so we have to regroup. So what do we have here? Well, we have 1/4, but we need to get enough so that we can take away 3/4. We have to take away this many pieces. So what do? Well, we regroup, we rename. So this 4 we're going to take out, and we're going to take a whole. And we're taking this 1 whole that we have right here, and we're cutting it into 4 pieces. So now look, we have enough. We can take away 1, 2, 3. And how many do we have left? Well, we're left with 1, 2. So we're left with 2/4. And now we have 3 wholes minus 3 wholes is 0 wholes. So our final answer is just 2/4. So now let's head to number 6. 2 and 1/4 minus 1 3/4. So they already have this model written for us. Notice this was our 2 wholes right here, and this was our 1/4. And we're taking away 1 3/4. So here's our 1 whole they took away for us, and then they're taking away these 3/4. So what are we left with? We're left with 2/4. Now off to number 7. This one's going to use a number line for us. So here, we started at 1 whole and 2/3. So notice here's the 1 whole we start at, and then we jump 1/2. And now notice they're having us go 2 wholes and 2/3. So where do we end up right here? Well, we end up at 4 wholes. And then notice it's 1 jump out of 3. So it's 4 1/3. Off to number 8. Notice we're subtracting. So when we subtract, remember we go to the left because we go smaller on the number line when we go to the left. So we start out at 2 3/4, and we're taking away 1 3/4. So we go to the left, and where do we end up at? Well, we're ending up at 1. So this one was really easy for us. And over here, we have 1 3/6. So here's our 1 hole, and here's 3/6. And then we have 1 hole and 3/6 here. So there's our 1 hole and 3/6. So what do we see when we add this together? Well, notice they're all the same size. They're all equal to 1 hole. So this is 1 plus 1 plus 1 hole. We have 3 holes here. Okay, number 10. So what do we have here? Well, here we have 2 holes, 1, 2 holes, and 3/5. So we have this much right here. And we're adding what? We're adding 1 hole and 3/5. So we're adding another 3/5 to this. 1, 2, 3, 4. So what do we see here? Well, notice we can take these 2 right here and we can fill them in up here. So now what do we have? Well, we have 1, 2, 3, 4 holes. And we have what? We have 1/5 left over. So our answer is 4 1/5. Heading off to number 11, what do we see? Well, here, we're going to try it without our models. So remember, we add our numerators. So we get 12/12. We add the whole numbers. And what do we notice? Well, we notice 12/12 is equal to what? It's equal to 1 hole. So we have 5 holes, and we're regrouping 1 hole. So that's 5 plus 1. So our answer is 6. Now off to number 12. Let's try this one also without that model. See if we can get that pattern so we're ready for tomorrow's lesson. 9 plus 7 is 16 over 10. 4 plus 3 is 7. And notice we have some holes hidden here. So we're going to take out 10/10, which would leave us with 6/10 left over. And that 10/10 we regroup. We're trading this 1 hole over here. So what do we have? Well, we would have 8 holes and 6/10 left over. Number 13, since we have a small denominator, let's try it with the model again. So here we have 5 holes. 1, 2, 3, 4, 5. So there's our 5 holes. And we'll just fill them in briefly. And then we have 3/4. So we're going to break this up into fourths. 1, 2, 3. And then what are we doing? Well, we're adding 2 holes. So here's 1 hole, 2 holes. 1, 2. And then we're adding 3/4 here. 1, 2, 3. So notice we can take this 1/4 right here and we can move it up to the top. We still have 3/4 that we added to it, but now we have holes. So let's see how many holes we have. We have 1, 2, 3, 4, 5, 6, 7, 8. So we have 8 holes, and then we have these 2/4 left over. So we have 8 and 2/4. Number 14. So here we have a ginormous one. We have 12 holes. So I'm going to just draw these lines, or these boxes. Let me start all the way over. So we're going to have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, and then 3/8. 1, 2, 3, 4, 5, 6, 7, 8. And then we need to shade 3 of those in. 1, 2, 3. So notice making these models or using number lines or fraction strips takes a while when we use these big numbers. That's why we're going to switch to the standard algorithm, the shorter way to do it when we move to that lesson tomorrow. So what do we need to do? Well, we need to take away 9 of them. So here is 1, 2, actually we'll do those x's. So 1, 2, 3, 4, 5, 6, 7, 8, 9. And then we need to take away 5/8. Well, notice we have a problem here. And what's that problem? We only have 1, 2, 3 that we can take away, and we have to take away 5. So we have to regroup this top one. 1, 2, 3, 4, 5, 6, 7, 8. And then, remember, we're training for a whole. And we need to take away 5 now. So let's see. 1, 2, 3, 4, 5. So how many pieces do we have left? We have 1, 2, 3, 4, 5, 6. So we have 6 pieces left out of 8. And how many holes do we have? We only have these 2 holes. So we have 2 and 6/8. Off to number 15 now. So here we have 8. So I'm just going to make a big box and say 1, 2, 3, 4, 5, 6, 7, and 8. And now what do we need to do? We have to have a third. So we're breaking this up into thirds. And remember, these bottom guys aren't filled in. And now we're taking away 2/3. Now we can't do that because we only have 1/3 here to take away. So we have to regroup one of these. Now I can take away those 2/3. And we're also taking away 7 holes. So that's 1, 2, 3, 4, 5, 6, 7. Whoa, look, we're only left with this left. We're only left with 2/3. Number 16. Let's see if you guys got the hang of it now without the models. Well, notice these 7/8, they're going to cancel out. We're going to have 0/8 left over. So we're just with 13 minus 10 is 3. So 3 and 0/8 is the same as 3 holes. And number 17. So here we're going to go back to our model again. We have 3 holes and 1/4. So here's 1, 2, 3. We're going to break this last one up into fourths. 1, 2, 3. And we're taking away 2 and 3/4. Well, notice we can't take away 3/4 because we only have 1/4. So we have to regroup this top one. And now we can take away those 3/4. So we took those away. We need to take away 2 holes. So what are we left with? We're left with just 2/4, again, like we've seen a few times during our answers. Off to number 18 now. Kit said, on summer vacation, I spent 1.5 weeks with my grandma and 1 week more with my aunt than with my grandma. How many weeks did she spend with her grandmother and her aunt? So we have to figure out the total. Use fraction strips or number lines to find the sum. Well, with her grandma, let's highlight it. She spent 1.5 weeks. And with her aunt, she spent 1 more week with my aunt than with my grandma. So it doesn't say she spent 1 total week. It's saying she spent 1 more week with her aunt than her grandma. So we have to figure out how much she spent with her grandma. So with her grandma, remember, she spent 1.5 week. And then what? She spent 1 more week than that. So she spent more time with her aunt than with her grandma. So she spent an extra week with her aunt there. So what do we have? Well, we have 1.5 plus the time she spent with her aunt is 2.5. So now what do we have here? Well, we have 1/2 plus 1/2 is 1 hole. Then we have 2 holes here, so that would be 3 holes, plus another 1 hole here. So how many weeks did she spend total? She spent 4 weeks total. So off to number 19. If Kit spent 3.5 weeks in swimming lessons, how much more time did Kit spend swimming than visiting spend visiting family than in swimming lessons. So here, remember, our previous problem, it said she spent 4 weeks, and we need to subtract 3.5 weeks because we're finding how much more time she spent with her family. So what would that be? Well, here with our model, since I should have done a model for our last one, but I didn't because I did not follow directions, we have 4 weeks, and we need to take away 3.5. Well, notice we can't take away a half, so we have to regroup this bottom one. So we regroup it, and now we can take away a half. We'll take away this half, and we need to take away 3 wholes. So 1, 2, 3. So what are we left with? We're left with just 1/2. So she spent just a half week longer with her family than she did for swimming practice. Number 20. Hannah used 1 5/8 gallon of paint for the ceiling and some gallons of paint for the walls. Hannah used 6 gallons of paint in total. How much paint did Hannah use for the walls? Well, here we have what? We have 6 gallons that she used in total. So that's what she started with. And then she used this much. So she took away this much from the 6 gallons. So how can we show that with the model? Well, like this. We're going to start, and we have 1, 2, 3, 4, 5, and 6 gallons. And we need to take away 1 5/8. Well, notice we can't take away 5/8 because they're all whole, so we have to break it up into 8. So 1, 2, 3, 4, 5, 6, 7, and 8. And we need to take away 5 of them. So 1, 2, 3, 4, 5. So we're left with this many 8s. We're left with 3 8s. And we need to take away 1 whole. So now how many holes are we left with? We're left with 1, 2, 3, 4 holes. So how much did she use for the walls? 4 3/8 of a gallon. Number 21. A furlong is a unit of length still used today in racing and agriculture. A race that is 8 furlongs is 1 mile. A furlong is 660 feet. How many furlongs are in 1 mile? So, they give us some extra information here. It says a furlong is a unit of length still used in racing today. A race that is 8 furlongs is 1 mile. A furlong is 160 feet. How many furlongs are in 1 mile? Well, notice how many furlongs are in 1 mile. It's asking us right at the top the answer that they already gave us to make sure we're paying attention. A race is 8 furlongs. So how many furlongs are in 1 mile? Well, it's just 8. So they gave us all this extra information. Now, what I think they wanted it to say was how many furlongs are in, or how many feet are in 1 mile, but that's not what they asked us for. So that's our answer here. Number 22. A recipe calls for 1 2/3 cups of brown sugar for granola bars and 1 3/4 cups of brown sugar for the topping. So apparently lots of sugar. Dara has 3 1/4 cups of brown sugar. Does she have enough to make the granola bars and the topping? Explain. Well, let's see how much total she has. She has 1 2/3, and she also has 1 1/3 that she needs. So what is that together? Well, together, that's going to equal what? Well, we have 1 2/3, and then we have another 1 1/3. So we're going to take that 1/3 and just move it up here. So how much do we see? Well, she has, I was going to erase our answer. She has 3 cups. Is that enough? No, it's not enough because she needs 3 1/4. So how can we explain this using our math symbols? We can say 3 1/4 is greater than 3. So Daria has enough. She only needed 3 cups of sugar, which we showed right here, and she has 3 1/4, so she has enough by 3/4. or not 3/4, she has enough by 1/4. Number 23, Megan is knitting a scarf. She has knitted 2 7/12 of a feet so far. She needs to knit another 2 11/12 of a foot so far. Which of the following expressions can Megan use to find the length of the completed scarf? So we need to add these two together. But it sounds like there may be something tricky. But let's see if there is. So do I see this model anywhere? Yeah, I see that expression at the very front. Let's check just to make sure. No, that doesn't have the 11/12 that we need to add. This one, they took the fraction numerator and they put it as the whole number. And here I have no idea where they got that 4 from. Probably 11 minus 7. So yes, our answer is just A. Now for number 24, Megan finishes the scarf. It is 5 6/12 of a foot long in length. She finds a mistake in her knitting and unravels 2 4/12 to correct the mistake. How long is the scarf now? So we start out with this number. We start out with 5 6/12, and she's taking away. She's unraveling, so she's pulling it apart. She pulls apart that much. So what do we have left? Well, we have 6 minus 4 is 2 over 12, and 5 minus 2 is 3. So does that answer match any of ours? Yes, it does. It matches C. And that is it, guys, for our lesson.